Hello and welcome. Some time ago I got this mainboard from a viewer of my channel. It consists of the mainboard itself and a very proprietary Razer card. The parts belong to a HP Vectra 386 office PC, which was a very reliable and expensive machine in the beginning of 90s. The mainboard brings an AMD 386SX CPU at 33 MHz. Also it has a built-in S3 video chip, which was quite good at the time. It is equipped with 4 128K memory chips, so 512K video memory in total, with an option to expand it to 1 MB using zip memory modules. And right next to it there are 4 32-pin SIM slots for the main memory. Here I also can see 4 512K memory chips, which should add up to 2 MB of onboard RAM, so the board should work without additional RAM modules. This is an interesting lever here, which should be flipped to push the mainboard out of the case. Inserting it back and flipping the lever would probably press the mainboard against the Razer backplane and fix it in place. By the way, this mainboard has no integrated battery, what is a huge thing. Otherwise, we would probably have already spilled electrolyte all over the place and a lot of damage. On the back, it looks quite ugly around the FPU socket, but it seems to be just some dirt, probably leftovers from the flux, as the socket was soldered like 40 years ago. Let's try to use some IPA. Yeah, looks good. There seems to be a resistor soldered to the video memory socket. It doesn't look beautiful, but this still could be a factory fix. Such fixes were quite common in OEM machines back then. Unfortunately, there seem to be a lot of scratches around the board. Some don't seem to be deep, others look quite ugly. I'd have to take a look through a microscope. Yeah, this one looks really bad. The trace is definitely cut through. This scratch is so deep, it even left a groove in the PCB. Looks like this is the worst one, but there are more of such scratches around. Here, for example, another one which goes over multiple traces. Okay, let's take a look at the Razer card. There are 2 connectors into which the mainboard gets inserted. I never saw the case in person, but I'm pretty sure that the Razer card is screwed in the case like that. And then, as I previously said, the mainboard slides into the case, and in the end this lever latches in. By flipping it, the mainboard is then pressed into the connectors on the Razer card. On the Razer card there seem to be multiple connectors. This looks like a floppy connector, and next to it is probably an IDE connector. The I/O controller chips and logic is located on the mainboard itself. And here is a battery connector for external battery. Well, then there are 3 ISA slots. One slot seems to be damaged mechanically. Yeah, looks like there was a serious impact. That looks better. At least now the contacts don't touch each other and the slot should be usable again. Okay, the power connector, which looks to be similar to a standard AT power connector, is most likely not. There are 10 silver color pins, which do remind on an AT power supply, but there are also 2 golden plated pins which look totally different. A standard AT PSU has 2 connectors, each with 5 pins. That makes 10 pins in total. It looks tempting to just connect those to the silver colored pins, but that would most probably fry the mainboard. We'll have to find out the proper pinout, so let's do that. This is a very common task on non-standard OEM machines. Actually, even if the power connector looks standard, it's always worth to compare the pinout with the standard AT. For example, there you have 4 ground pins in the middle and 3 plus 5 volt pins on one side. So it is usually sufficient to start with those. For example, if 4 pins in the middle are not connected with each other, you have a proprietary connector and shouldn't use a standard AT power supply. Yeah, the 4 pins in the middle are not connected. This is definitely not an AT power connector. But what is it then? How can you easily determine which pin with which voltage? Easy, you just need points of relation. For example, take ISA Pinout. It has ground on B1, plus 5 volts on B3, minus 5 volts on B5, minus 12 volts on B7, and plus 12 volts on pin B9. Those are our points of relation. Let's start with ground, which is the pin B1. One probe of the multimeter goes there. With the other one, we go over the pins of the power connector. So these 3 pins are all ground. Good, let's write it down. Okay, next one is pin B3 in the ISA slot, which is plus 5 volts. These 3 pins are plus 5 volts as it seems. Let's make a note and continue for all the other voltages. Okay, I found all the voltages, but so far I don't know what the 2 most right golden pins are for. Maybe that is power good signal or something like that. Let's come back to it later. As long as we know all the voltage pins, it should be sufficient to power on the system. So, from left to right, we have minus 5 volts, minus 12 volts, then 3 plus 5 volts pin. This is where the systems pulled the most power from back in the days. Then we have 2 plus 12 volt pins and 3 ground pins. As I said, the 2 most right pins, I don't know yet what they are for. Now, where to get a custom PSU with this pinout? This is of course not the first time I have such a problem on my workbench, and for such cases I made some wires. On one end I soldered a clamp, or whatever the proper name is. On the other end I soldered a thick copper wire, so the clamps can be pushed into the related pins in the connector. I use color-coded cables. Black is ground, red is plus 5 volts and yellow is plus 12 volts. Usually you don't need negative voltages to initialize the system. Minus 5 volts is likely to be not used at all from the mainboards itself. It is mostly for expansion cards, and minus 12 volts is for serial port and is also usually not absolutely necessary. So for now I'll stick to positive voltages only, and of course the ground. So the other end of the wires can be inserted into the AT cable as required. Of course, red goes to plus 5 volts, yellow to plus 12 volts, etc. The thicker copper pins which are soldered in the end of the wires is thick enough to sit tightly in the PSU connector. Perfect. Now, before we connect this thing to the mainboard, let's check that all of the voltages are as required. Plus 5 volts, we have no minus 5 volts and no minus 12 volts as expected. Plus 12 volts, well, plus 11.3 volts actually, but it's good enough. By the way, this Razer card has also checkpoints with inscriptions on the PCB, which could be also used, but I wanted to show the method with the ISA slot because such checkpoints are not very common. Okay. Let's connect the mainboard to the Razer card and see if we get some signs of life. I know that there are some broken traces, but maybe we can see if it's worth to continue at all. Of course, a post analyzer would help as well. So, it shows no signs of life. No beeping, no numbers on the post analyzer, no nothing. Well, would be too much to expect it working with those scratches on the PCB all over the place. At least the chips are getting warm, so the power is there. Let's make some measurements, I would say. The clock generator gives us a nice 66 MHz sine wave, which is perfect. The CPU is a 33 MHz version and needs double clock, which is apparently 66 MHz. And the same 66 MHz I can measure on the CPU, so the clock is propagated properly. And the CPU is very warm, so it gets the power, it gets the clock, we should be able to see some signs of life. But you know what? With those bad scratches and broken traces, it just makes no sense to poke around. So far everything looks good, but those physical damages have to be fixed first. Who knows what those traces are responsible for? Well, I checked those scratches under a microscope and most of them look worse than they are. Even such a bad looking scratch like this one is actually only on the surface. I measured the continuity and it's fine. Also, spraying some alcohol on the scratch helps to see it better. The alcohol runs into the scratch and flattens the surface. Then suddenly it looks not half as bad as before and the traces are visibly not damaged. Beautiful world of physics. All a matter of light. Once the alcohol evaporates, it looks just as bad as before. However, one spot is definitely a damage. This deep scratch near the top edge of the PCB. Here, a trace was damaged and needs to be soldered. And despite of having 50 scratches or so, this one turned out to be the only one where a trace has been actually affected. And it's done. Let's check if something has changed. Nope, still doesn't look good. The reset LED on the post analyzer seems to not switch off. Normally that signal should be on for a while, then turn off and the system should start to post. If the board is stuck in reset state, it will never post. So, I searched for the reset pin on the board where a button usually gets connected and I didn't find any. However, I found this command panel header instead. This is basically nothing else but a connector for all the front panel LEDs and buttons, like reset, which I need. Unfortunately, I couldn't find any pinout documentation, but I found some pictures of a very similar PC on eBay, HP Vectra 38620N, And this one has a slightly different mainboard, slower CPU and graphics chip, but that still is very similar. Among photos of the case, there were also some shots of the internals. First, what caught my eye was the power connector, and at least judging by colors, I got the voltages right. Still, there are those mysterious blue and white cables, but everything else matches. Now to the really interesting part, the front panel. From inside we can clearly see that there is only one ribbon cable which goes from the front panel to the Razer. That is interesting because the power switch is located on the same front panel. Now, if we take any standard AT-PC from that time, we will find a big mains switch to turn on the power. This is not the case on the HP Vectra 386. There we obviously have a digital switch because such a ribbon cable is not made for mains voltage. Well, this means that the blue and the white cables on the power connector must be the digital signal pins which would turn on the original PSU, like the green pin on the ATX power connector, which turns on the PSU when it is connected to the ground. So the PSU in the HP Vectra 386 was very advanced for its time, but that still doesn't explain why the board is not turning on. I'm using a normal AT PSU which doesn't need those additional pins. I searched the retro web and found two pictures of the front panel for the HP Vectra 38620N. Unfortunately, the pictures of the back of the front panel is not good. The PCB is covered with a ribbon cable and it is not visible where traces are going to. I asked on German DOS Reloaded.de forum, and one user shared pictures of a similar HP Vectra 486 machine. The front panel looks very similar, but the ribbon cable is narrower and has obviously different pinout. The only one thing which I took from it is that under the switch there are more than just two traces which get connected. But otherwise, unfortunately, I don't know which pins on the front panel header are going where. So the last stupid idea I got was to just short the pins in the header and see if I can find a reset line. This is a stupid idea because it is possible to short something on the board and destroy it, so don't do it at home. Next steps took some time, so let me summarize what I tried. Shorting the two pins on the power connector didn't change anything. Also, shorting those pins to the ground didn't make a change. I found that those two mystery pins from the power connector are directly connected to the front panel header on pins 7 and 8. Also, I found out that the pins 3 and 14 are connected to the ground, so I started to short the pins around pin 7 and 8 with each other and to the ground with a pair of tweezers. Lucky me, after some tries, the reset signal was cleared and some numbers started to run on the post analyzer card. So, finally, to switch the PSU on, the pins 7 and 8 have to be connected. That will turn on the mains inside of the PSU and the mainboard will get the required voltages. However, the mainboard will remain in reset state until pins 5 and 10 on the front panel header are pulled high. Actually, it seems to be sufficient to put a jumper across pins 5 and 7 because they are next to each other, but connecting pins 7 and 10 works as well. These all has to do with the original HP Vectra PSU and how it is turned on. But in this case, when using a normal AT PSU, it seems to be sufficient to connect pins 5 and 7. I still have no clue what the other pins are for. Of course, they are for power, turbo and HD LEDs, as well as turbo button, I suppose. But so far I couldn't find out which is which. I documented my findings and uploaded a PDF on the retro web. If you have such a machine, feel free to complete the missing parts. Now, where the board seems to turn on, let's see if we get somewhere. Ha! And it's beeping. How cool is that? Let me connect the VGA cable to check if there is a video signal. Nope. No video signal at all. The chips are warm though. So I investigated a little bit, and it is so that the system doesn't need minus 12 volts to initialize, as well as minus 5 volts, but some VGA cards, in particular RAM decks, which are responsible for digital to analog video signal conversion, can require minus 12 volts as reference voltage. The graphics chip, in this case, it is on board S3, talks to its RAM deck and initializes that. If something goes wrong, the graphics card doesn't finalize the initialization, so on some boards, minus 12 volts are mandatory and are not only used for serial ports, but also in the video output circuit. To test that, I made another small cable, an orange one this time, to use it for minus 12 volts power line. As I previously found out, that has to be the second pin from the end. Also, as you see, I insulated the end of the wire so that the clamp doesn't short to plus 5 volts rail nearby. That could be potentially deadly for the board. And we have minus 12 volts. Nice. But you know what? I'm a little bit nervous that the clamps on the other voltage wires are exposed like that. Would be bad if I accidentally touch those ends, or if they slide off the connector and touch each other. The minus 12 volts wire looks good, so let me insulate the other wires in the same way before I do anything else. Yeah, looks much safer. Unfortunately, I don't have shrink tubes in every color and size, so it's now red for plus 5 volts and blue for everything else. The color of the cable is then the marker. Okay, let's give it a try, now with minus 12 volts connected. Nope, still no video signal. And now the postcode hangs at 5. Strange. Let's disconnect minus 12 volts once again. Oh, now it posts again, but there is no video signal. You know what? Let me try an external VGA card. I'd also have to disable the onboard graphics adapter. There is a switch which has a mark VGA enable on position 3. The documentation from the retro web says that off means enabled and on means disabled. Okay, let's turn the onboard VGA chip off by flipping the switch 3 to on. The board posts, but there is still no video signal. Well, let's reconnect minus 12 volts once again. And would you look at that, we have a video signal. Wow, the BIOS seems to be in German. Okay. HP Vectra PC. There are some errors. Systemkarte has an error. Keyboard and mouse is a warning. And system configuration has an error too. Here down below we have some error codes, and it says that I should press enter to see explanation of the error codes. Unfortunately, I didn't connect the keyboard yet. Let me change that and reboot once again. By the way, never connect or disconnect an AT or PS2 keyboard to or from a running PC. That could potentially damage the mainboard. Always turn off the power first. Okay, the keyboard is connected and the warning has disappeared. Now it's okay. Good, so let's see. Enter. Fehlermeldung 1 von 5, Fehlercode 0210 or error report 1 from 5, error code 2C0. Die im EEPROM-Speicher gespeicherte Masterkonfiguration ist verloren. Aha, I see. This says that the configuration in the EEPROM was lost. I guess this relates to the missing battery and forgotten BIOS settings. Second error 0241, Systemkonfiguration ist verloren gegangen. That is basically the same error as the first one. The system settings were lost. Error 0280. Again the same. They seem all to be due to the missing CMOS battery. 0250. Stimmt nicht mit der tatsächlichen Hardware. So something about hardware mismatch in the settings. Yeah, and the last error, again the same. All the errors are somehow related to faulty, lost or missing BIOS settings, which is result of a missing battery. Good, let's connect the battery. We have to find out where is ground and where is plus. This pin seems to be connected to ground, so this is where the black wire goes to. I have a 3 volts battery pack here. Red wire is plus and black wire is obviously minus. So, setup, press F2. Ha! Date and time and warning regarding battery error. It says that the checksums are faulty. Okay, press enter. Finally, we are in BIOS. Let's see what we can set here. Of course, time and date. Processor 386SX. Here I seem not be able to change anything. Page down and up doesn't change the value. Der nächste Wert F8. For the next value you should use F8. Okay. Oh, I can switch between automatic and high. Probably some kind of turbo on-off thing. Coprocessor, user password, display shutdown is turned off. I guess some power saving features, I'm not sure to be honest. Keyboard click volume doesn't matter now. Numlock default on. Memory, 2 megabytes in total. That was the onboard memory, that's right. Hard drives, disk 1, none or SCSI, interface integrated. Okay, this can be switched. And here you can enter the disk geometry, things like cylinders, heads and so on. Let's put it to none for now. Here you can set the SCSI ROM address and memory shadow. Probably this PC was also delivered with an optional SCSI card. It's irrelevant now. Floppy disk. We have none connected. Security settings. Setup password. Network mode. Put from floppy. Blah blah blah. Currently irrelevant too. Parallel and serial interface ports. External program start. Whatever that means. Have currently no clue. Video, EGA, VGA type. Oh, you can also set ROM shadow, which improves video performance in DOS. Oh, you can even set the video mode sync clock. How exciting. And last but not least, the BIOS version is 4.01. Okay, let's take a deeper look into it later and try to save the settings. Nope, that didn't work at all. My bad. The switches on the board allow to enable or disable configuration and the flash. Previously I switched those on, but also here the documentation says that on means off. So let's try it once again. And when you look at that, this time the settings have been saved properly and the error disappears. Nice. Now it reports a system start error. Well, there is neither floppy drive connected nor a hard disk, so that's totally expected. But before trying to boot, let's try the integrated graphics chip once again. It still bothers me that it didn't work. The external card definitely needs minus 12 volts and this switch has to be turned on. So for the integrated cards it has to be off. And I played with the switches previously and maybe I mixed something just like with the BIOS settings. Nope. Seems to... Wait! Oh, look at that! I have no clue why it works now. Let me reboot once again. Yep, it just works. This briefly an S3 BIOS message visible, and also post-screen reports now integrated graphics. Witchery. Let's configure the hard disk, or better to say my compact flash card, which I usually use in most of my videos. So this BIOS is completely in German, and also the abbreviations are of course all in German too. Zöll stands for cylinder or cylinder in English. KP is probably Köpfe, means heads. SK must be Sektoren or sectors. Well, those are the important settings. The rest is probably prefetch, park, and whatever XL means. I leave those settings at default. My compact flash card has 987 cylinders, 16 heads, and 63 sectors. The size is automatically calculated to 510 megabytes, which is about right. Let's try to save the settings. Yep, it reports Festplattenlaufwerk C, which means hard disk drive C. And the test fails, of course, because I didn't yet insert the compact flash card. Let's fix that. Here's the card. As you see, I printed the geometry on it, so I always know what to put in BIOS. I have multiple cards and they have different sizes and so different geometries. That's why such a sticker is always helpful. And would you look at that, it reports 510 megabytes hard drive and the tests was okay. Starting MS-DOS. Wow, it actually is booting from the compact flash card. Marvelous. That is not a given that it detects the compact flash card. I had many 4, 3 and 286 PCs of similar age with the integrated I/O controllers, which didn't want to work with a compact flash card. Usually rather because of the BIOS issues than anything in hardware. But anyway, this system holds up so far quite well. Landmark speed test reports 386SX33 as expected. The CPU performance is about right, I think. And look at the video performance. Over 4000 characters a millisecond. That is outstanding performance actually. Sysinfo says 24.6 points, which is I think a good value once again for a 33 MHz 386SX. Let's see where NSSI will put its performance in relation to other systems. It is faster than a 386DX25 and almost twice as fast as a 386SX16, which is about right with its 33 MHz. Back in the days, performance of the CPU grew linear with its clock, since CPUs didn't have sophisticated pipelines and vectorizations and all that stuff. Cool, it's fast 386SX as far as I can tell, and of course as fast as a 386SX can be. Let's do something with graphics, for example 3D Bench. By the way, sometimes I get a question where this benchmark suite for DOS can be downloaded. This set of tools is actually very famous and was prepared by Phil from Phil's Computer Lab. You can download it from his project page. I will put the link down in the description, and also from me here once again a big thank you on Phil for putting this together. It is a very handy and easy to use setup. And in 3D Bench we are getting 9.2 points. I looked into my notes and I got 4.9 on a tweaked 386SX16 in one of my previous tests. So 9.2 seems reasonable for me. Let's try again. This system is a perfect fit for Wolfenstein 3D. Works fine, PC speaker sounds works as well. Another game which was actually already running well on a 286 is Commander Keen. In this case part 4, and a 386SX is of course a pleasure to play this game. By the way, Commander Keen and Wolfenstein 3D were both made by id Software, and if you play Wolfenstein 3D with PC speaker, you will recognize some of the sound effects which it inherited from Commander Keen. Well, and although this makes no sense, as always, we have to start Doom on this machine. However, it will not run with 2 megabytes of RAM, since Doom needs at least 4 megabytes. Well, even then, Doom will not run here, but at least it should start to crawl. I'll insert 4 modules, 1 megabyte each. With 2 megabytes of onboard memory, this should sum up to 6 megabytes of total memory. By the way, the documentation says that if you use 4 modules with 4 megabytes, the onboard memory has to be deactivated. That is because 386SX supports maximum 16 megabytes RAM, and with 2 megabytes on board, we get 18. This looks funny. All 4 modules are from different sets, but they are all 1 megabyte and they all work. I used those in another systems already many times. And the BIOS reports 6 megabytes of RAM indeed, but we get an error. Yeah, the error code description tells that the saved system configuration doesn't match the actual one. Let's enter the BIOS. Yeah, here it says that the memory size has changed. Okay, here it reports 6 megabytes total memory. Looks good to me. Let's save and reboot. Back in DOS, and sysinfo reports now 6 megabytes of memory. Well, it says 5.1 megabytes extended, which is above 1 megabyte limit, plus 640 in DOS below that limit, plus the memory between 640 and 1024K, which is not shown here. That's total of 6 megabytes. So the whole memory is detected. 6 megabytes for a 386SX back in the days was insane amount of memory. Most of such systems had 1 megabyte, maybe 2 if you were really rich. 6 megabytes was something from outer space. Just like Doom as it came out, and with 6 megabytes on the system we finally can see how it looks. Yikes. Well, starting a game doesn't mean playing a game. A 386SX was not able to run it. And I made a video about it a couple of years ago, and if you're interested which system you needed back in the days to enjoy Doom, feel free to watch that. And for today, this is it, I would say. This system is totally running. I had to improvise a bit with the PSU, but that worked. Also, I was surprised that regardless of all of the scratches, only one trace was damaged. Now, it should be fine again. I'm glad that the onboard graphics chip is totally working. I have no clue why it didn't work on the first try. My suspicion is that the switches could have been oxidized, and after I switched those back and forward a couple of times, the onboard graphics chip started to work. I really have no explanation otherwise. Also, that the onboard memory can be used in combination with the SIM slots is quite nice. 2 megabytes on this board is a lot. What else? Yeah. Getting the system out of the reset state was a bit tricky. The front panel header pinout wasn't quite obvious. It is unfortunately still half mystery, but at least I found out how to start the system. Once again, I documented my findings on the RetroWeb, but if you have something to add, feel free to write a comment. Contact me or somebody else from the Retro Hardware team, that would be great. Unfortunately, I have no case for this mainboard, and it will be very hard to find it, I'm afraid. I asked my patrons and also on DOSReloaded.de and on Blue Sky if someone has such a case or needs a mainboard to complete this nice and rare system, but so far, unfortunately, I got no answers. Well, I'll store this board for a while, maybe there will be an opportunity to find a nice home for it. And this is it for today. I'm excited about your feedback, and as always, thank you for watching, and goodbye.